Jakob is my name. I'm Swedish, obviously, and I guess a couple of you have already read the entire presentation because it's right there. And if you want to read it after, obviously, you can just go there. And I'm here to talk about Node.js, actually, which is funny because this is a Frontend conference. Also, obviously, I don't speak Russian, so I'm not doing anything right yet. But anyway, just a little bit about myself first. I started out doing consulting, coding in a suit and so on, and that got tiresome pretty quickly. So I got into startups instead. And by now, I've had time to work with 3 different startups. The first one in recruiting, the second one in advertising, and the third one that I'm working with right now in customer feedback. And just some small glimpses of what I've been doing then was that in the second company, we were processing about 2 billion writes to our database every day. So a lot of data, and we were storing all of this, processing it, collecting it, drawing conclusions, massive data. And in the second one, or the third one rather, the one I'm working with now, we're doing quick and easy customer feedback for brick and mortar stores. So not online, but for shops and pharmacies and grocery stores and retailers and so on. But it still collects data and becomes like Google Analytics, but for real life. But I'm not here to talk about the companies I'm working with, but I'm here to talk about writing RESTful web services using Node.js. And the reason that's interesting, and the reason I believe at least that I'm talking about this for you guys, is that JavaScript is what you know already. So being able to use the same tool for different kinds of purposes is always interesting and might broaden your perspectives a little. So this talk could be a comparison between different technologies and the nitty-gritty details and the rocket science, so to speak, of writing such a server. And it could also be some kind of product demo or a silver bullet of how you should do things. But that's obviously not the case. That's not what I'm going to talk about. So what am I going to talk about? I tried to come up with a couple of words to describe it instead, and I think this is better. I want to tickle your imagination a little, inspire you, and I want to go through a large quantity of things. So I'm not going to deep dive into anything, but rather talk about lots of small things. And we're going to take a bottom-up perspective, so even if you've never even heard of Node, you're going to understand what I'm talking about, but I'm going to do it in a quick pace, and yeah, probably reach some things that you haven't heard of. And last but not least, I'm going to talk about some principles when working with these kinds of things, and some general ideas that I think you could take with you. So we're going to go from 0 to getting a server up and running, getting, setting, and updating data, and declaring this interface that the service is going to have, and also authentication, which is mandatory, of course. And since being Swedish, speaking English, and doing backend at the Frontend conference is not enough, I'm also going to throw in some CoffeeScript. And if you're not familiar with CoffeeScript, this is a super quick tutorial that you have to read and understand right now, so you can follow the slides. It's actually really simple. CoffeeScript on the left, JavaScript on the right. You don't have to write var before your variables. You don't have to write any semicolons. Functions are declared by, well, simply skip function, skip return, and skip the curly braces, and just write the parameters and an arrow and then what you want your function to do. Really terse, really simple. And objects can be declared with indentation rather than curly brackets. And you can also, like in the last line, call a function without the parentheses. So you just write the arguments right after the function name. So this makes the slides a lot easier to read, hopefully. So Node.js. Let's start from the very beginning. How do you get Node.js? You go there, you click there, bam, done. You have it. What is it? It's a platform built on Chrome's JavaScript runtime, and it's built for easily building scalable network applications. And as it says right here, Node uses an event-driven, non-blocking I/O model that makes it lightweight and efficient and perfect for processing real-time data. And this is just copy and pasted from their site. There's actually quite a lot of controversy around whether this is actually correct, but we don't have time to dive into that now. We're going to get our hands dirty instead. So let's focus on the parts that are actually interesting to us right now. So it's a platform. It's not a language. It's JavaScript. You already know it. And it's not a runtime. It's using Chrome's JavaScript runtime. So it's just that little layer of things that helps you to do something useful. And in this case, writing server software, network applications. And it uses an event-driven and non-blocking model. And since you're all familiar with JavaScript, you probably understand that completely already, but some of you might not have thought about it. So a quick example from Node. This is an actual program where we just require a module that's called fs, the file system. And then we call the function readFile, and we read this meaningoflife.txt as UTF-8, and then we pass in a callback, accepting an error and some data, and this data will then be the content of this file. And at the very end, we print end. Now, in most other languages, we would get to the point where we read this file, and then the server stops until this file has been read and prints out the result. But this is not what's going to happen here. We will start reading the file, and then the server will continue and print this end statement, and it will not print the data in the file until it has been read from disk. So it's exactly like when you do Ajax in the front end. How many are really, really familiar with this already? Hands up. A bunch, but not all. That's good. That's good. So the output will be like this. It will first print end, and then it will print 42, obviously. So that's the basic premise. And Node has a couple of protocols built in, because the entire purpose of it is to make it easy for you to write network applications. So TCP and HTTP and a lot of other protocols are already built in, and you can start using them just like this. All the examples I'm showing, by the way, are complete programs. It's not like something copy and pasted out, for example. This is an actual program that you can run. And here we require the HTTP module. And what we do on the last line is that we say that we want to create a server. We pass in a function that will handle the requests, and we say what port to listen to for the server. And the function itself, it just takes a request and a response object. The request object contains what you would expect, all the headers, all the cookies, the bodies of the request, everything that comes with a request. And the response object is something that has a couple of methods that helps you to actually send a response back to the client. So in this case, we ignore the request argument, and we just say respond with a 200 content type, plain text, and just write hello world. So this server will listen to our port, and whatever you send to it, it will respond with hello world. But it runs, and this is all you need. But we want to do something more fancy, right? So then we should have a look at npm, which is the Node package manager that you might have used. How many have used it? That's good. Again, like half. So it's pretty much like Ruby Gems is for Ruby, or what Nugget is to C#, and yeah, I guess pretty much all languages have something like this now. You use it to install and publish your programs that you have written. And to quote the author, it manages dependencies and does other cool stuff. And you install modules on the command line, just by saying npm install and then the name of the module. And you can, for example, use underscore, just like in the browser. And the program can make use of underscore just by requiring it and then start using this variable that has been returned. So we can use range and last and all those things that underscore has. But we want to have some modules that helps us building these servers, right? So one of the simple, interesting ones that introduces a concept that's very useful is Connect. And Connect is a middleware framework. It helps you build reusable components for your servers. And it ships with a couple of such components to begin with. 18 at the time I wrote this, probably more by now. And there's tons of third-party middleware for it. And we get started just by saying npm install connect, and suddenly we have it. And we can start using it very easily. We just require connect. And when we invoke this connect function, it creates the callback that's used to answer the requests. And by default, we're not really doing anything. This will not respond with anything. It's just equivalent to creating this the server the same way as we did before. But if we want to do something then, we can suddenly start using this app object that connect returned to write out a sequence of tasks that we want to perform when the request comes in. So we don't have to build one giant method that does everything we should do with a request, but rather we can split it into simple parts that we can reuse. And I've just made a stupid example here where I first do some basic authentication using a built-in module in Connect. And this little module expects a username and a password. Those are passed in from the request object that you have sent to the server. And then I check, is the username Jakob and the password FTC13? If so, we return true, otherwise false. And if that returns false, the rest of the execution will not happen at all, and an error will be returned to the one who sent the request. But if it passes true, then we get on to the next task here, and so on. So we can build a series of tasks that we want to perform and split these into reusable components. And there are lots of built-in tools with Connect, as I said. So you don't have to read the lists, but just understand that there's a lot for all the tasks you could need. So moving on, we need something more powerful to really do everything we want. So a typical framework that's used for web applications is Express, which is what they call a high-performance, high-class web development kit for Node.js. And by now, you probably understand that you just say npm install Express, and you have it. And you can use it like this, for example. While Connect splits the different pieces into a series and runs them after each other, Express is for branching out on the side, so to speak, not on the depth. So here instead we say that if I get a GET request with the path / then I want this piece of code to handle it. And if I get a GET request with /users followed by an ID, I want this piece of code to handle it. And I could, of course, combine this with Connect and right before all of these say the authentication thing I had on the slide before to have authentication for all these paths. But this way we can answer to different routes with different responses. And like I said, we can combine these. So if I create a couple of helper methods, for example, this before one up here, where we add something custom to our request object, just as an example of how we could modify it. We could add some default headers or whatever. And then we can say that these two / and /users are using these pre-processing parts before 1 and before 2. and they don't have to use both of them. But if we go to the slash path, we just use before one. So we add this foobar to our request. While if we go to the users path, we do both before one and before two. So it's two different ways to split down reusable components. So now we can respond and act on a lot of different requests, and we can do different tasks and split up how we want to handle all of this. So we should start storing data somehow. And as you understand, I've been doing startups for quite a while, and building something small really quickly is very important then. Just get something out there, get the product out. And we've been looking a lot at the NoSQL databases, like MongoDB and Redis and Cassandra and all of these. And it kind of becomes like this. Which one should I really choose? And even if we want to go with SQL databases, there are several. And I think one of the insights I've had while working is that the idea of NoSQL being schemaless, that's pretty much a lie. Because even if you don't have to write a schema up front and like define this is what my database should look like, you still define what it's doing by the way you interact with it. You expect it to contain certain data. You put certain data into it. You have a schema even if you haven't really been forced to write it. And that led me to explore some interesting tools. So in this case, we're going to look at MongoDB, which is really easy to set up and fits very well into the Node architecture. And there's a tool called Mongoose for actually modeling and describing how you want to use your database. So yeah, object modeling tool designed to work in an asynchronous environment, which is Node, so that's perfect. So once again, we go back to npm, we install Mongoose, and now I assume that MongoDB has been installed. There's no slide for that, but it's also a very simple installation. And if you do that and you start MongoDB, you could write a program that looks like this, for example, where we require Mongoose, just like we required the file system and the HTTP module and so on. We connect it to a database, and in this case, let's build a little blog. Let's call it Tumblr. And I've made a small helper function. You don't have to understand the exact details. We just pass in a name and some description of what we want this data to look like. So we can use that to create a model that we call users. And we say that a user has a name, a bio, and an age. And the name should be a string, and it should default to the empty string. And the bio should be a string, and it should default to IE6 lover, which is a perfect way to get people to actually write a bio. And then we can have an age and so on. So we just define what kind of data we're expecting to store. And we add some more on. We say that we're going to have blogs, and the blogs have a name and a description, and they belong to a user. And then we have posts which are belonging to blogs, and they have a date when they were published, and a title, and body, and so on. And when we've done this, Mongoose supplies us with a couple of methods to interact with this data and do all of the validations automatically. Much like what would happen in SQL if you wrote the schema and created the database up front. But in this case, we can do it on the fly. This is JavaScript that executes this specification, and we can change it whenever we want to. We don't have to rebuild the database to do that. So the typical method when doing RESTful web services is to be able to list your resources, to get a particular resource, to delete one, to update or put one, and create a new one. And all of these can be done as one-liners if we do the things we did on the past couple of slides. So the only thing we have to do is to pass in one of these models that we created along with, or rather, along with an ID of an object that we want to get out that matches that ID, or we can create a new object by, say, passing in the model and the data we want to contain in that model. Let me make a simpler example. So here we're back to the express case, where we say if the user sends us a GET request at /users and /an ID, then pick out the ID from the request, and all these variables that were written in the string are available at the request.params. And then we pass that ID into the GET function that we just declared over here, like this. And then we get back an error or some data. And we can send that data back to the client as JSON by just calling .json on the response object. So this is really it. Now it's actually doing this. The server is running, it's storing data, it's validating it against your schema, and it's all fine. So we just have the get method, and we could start copy and pasting that one, creating all of these, because we want to be able to post users, post blogs, delete posts, everything. But of course, we shouldn't be copy and pasting those pieces of code. We could do something smarter. If we just think for a minute, we could add all the models to some array, and then we could iterate over each and every one of the models, and just set up all these 5 methods for every single one. Get, just like we did before. Oh, this hash syntax, by the way, for strings, just inserts the value of that variable into the string, if you're unfamiliar with CoffeeScript. So it just puts the model name there in all those places. And then we use the methods that we defined for the database in combination with responding to posts and gets and puts and so on. And it's actually very straightforward. We just pass the data, pass the IDs right in. Nothing complicated. And this suddenly lets our server respond to all of these. And it receives data as JSON, it passes data back as JSON, everything is validated, and works perfectly. So what about relations? I mean, if we want to, for example, get all the blogs that a user have created, or get all the posts belonging to a blog, we want to be able to answer requests that look something like this. So for user 42, get me all the blogs. And once again, it's no rocket science here. You don't have to read the details. It's a little gory on the top. But it's just to show that it doesn't take a lot of code, and Mongoose helps you with a lot of these things. So just a couple of lines, and we can suddenly handle that as well. And boom, this works. So using exactly this idea, you could keep on generating your interface from data. You're actually just writing these models down as JavaScript objects, saying, these should be my default values. These should be the types of things. These are the relations between my different models. And the interface, the server, it's just generated from your data. So it's a very beautiful way to just get something up and working really, really quickly. And obviously, we need some kind of authentication as well, if this is to be something serious. And there are tons of different ways of doing this, obviously. One very nice way is to use something called Passport, which is kind of a framework is a strong word, but a tool for writing authentications using different kinds of services. So we first install Passport, and then we can install Passport plugins that authenticate using various schemes. For example, we could authenticate using Twitter or Facebook or OAuth or whatever. And in this case, we're just going to do a local authentication based on some data we have ourselves. Oops. So, yeah, once again, the code is just a couple of lines. We include Passport, we include this passport local, which is the strategy, as they call it. And we just have to implement a function that compares a given username and a given password to some data that we have in our database. So this find user please is a method I've just left out. That has to be implemented somehow. And it should just take a username and a password and decide whether or not that user exists. Is the information correct? So we should look in our database or something like that. And then we run these passport initialize and passport authenticate methods as plugins for connect using app.use, just like before. And if we were to do this using Twitter authentication, for example, we would do something very similar. We would just write down what's our API keys and so on for using Twitter, and a very similar piece of code down here, where we, instead of using the find user please method, we do another method where we pass in a Twitter ID and we look up, have we seen that user before? Or should we create it as a new user in our database? But the authentication itself, the passwords and so on, is handled by Twitter. So that's actually all you need. I haven't left a single line of code out. You could just copy and paste this, and you have a server, and you just modify what the data should look like, and it's all there. It's all up and running. So you could start doing that. You could all go back home and just throw something up and start using it. But that brings us to the second part of this presentation, which is convention. Because the downside of making it very, very easy to get something up and running and start doing something is that everyone is going to do it in a different way. And systems won't be able to talk to each other. And just like many other speakers before me today, I'm a little opinionated, so don't take it too literally. These are my opinions, and it's not necessarily based on facts. But I think it's more important to find a convention and define one yourself and stick to it than it is to use a particular convention. Just decide how you want to do things and do it that way. And this is the way I'm defining it for myself. So first off, when you have these paths to your resources in the API, you have to use either verbs or nouns to describe them, and there should be a clear separation here. We use nouns, things, that is, for all the things that we're storing and updating. We have like users, blogs, posts. Those are nouns. And we use all the typical operations for them. We can get the full list of users. We can get a particular user. We can post to the list of users. We can update a particular user. We can delete the list of users, or we can delete one user. Those are the basic operations. And it should all be done on nouns. And then we have the associations, which it starts with these, and for each of them we can go deeper. So for a particular user, get the blogs. And we could keep doing this. We could say for user 42, get the blog 314 and the posts of that blog. But doing that would be kind of like saying, yeah, press up to go up and press down to go down. We already know that if we get the blog posts from blog number 314, we already know which user that is. We don't have to write that out. So we don't need the bottom case, we just need those. So don't over-qualify URLs. Keep them simple and don't make more than you need. And then if you want to add something extra to your requests, like you want to filter all the posts based on some tag or something, then use the query string for that, because the path itself should just identify the resource, not your request-specific data. And then there's the whole discussion about like versions. If you update things and you want them to be compatible backwards. There are two different ideas here. You could do it in the head of your request, like with a header, or you can add it to your pods. Like you append it in the beginning and say this goes to version 1 of my interface. And I think this way is better because you can't manipulate the headers in all situations. For example, if you're doing a cross-domain request using JSONP or something like that, you can't control headers, but you can control the path you are accessing. And there are some more things that you should take into consideration working with this, like how to do partial responses. Come up with how do we decide what we want to get out from each object we're returning. Like, do we want the whole user, or would we just want the email and the age? And do we want to limit them? Like, get the 10 first ones. Decide on the wording you use here and the different parameters you have. Because if you can reuse this as well, it becomes a lot easier to build new things and make them work together. And then we have the verbs again, because we don't just necessarily do storing of this data that we had, but maybe we can do other operations as well. For example, if we were to do some calculation, convert euros to Belarusian rubles, we could do it like this. And then we actually have a verb here. That's how we separate this. This is just a computation. It's not storing data. So it says convert. And why you would want to do currency conversion in a blogging engine, I don't know. But and content types. It's pretty much the same thing as versioning. You can add it to the end of your pods, or you could do it in a header, but it's the same thing as with versions if you do it in the header. So this way it gets a lot more, it gets more compatible with different kinds of ways of making the requests. And then you should obviously think about the attributes you have as well in the data you return. I usually write everything using camel case because that's the way we usually write JavaScript. So it becomes easy to consume the service on the client side if it looks like this. And we should also do search somehow. Any good system can search, right? So we can use the verb search to perform an operation, just like we did with a calculation, and search for something in our database. Or we can use a path where we qualify what kind of data we want to look at, and then do a search in there. So we have just decided that the Q parameter should be reserved for search. You cannot use it for anything else. And with all these things in mind, you can just, for all cases I've shown here, all these conventions, it's very easy to just write a couple of lines of Node to handle exactly these things and get it all up and running. And for the authentication part, please don't reinvent things and just make it overly complicated. Just reuse what's out there and make a simple, clean solution, and don't do layer after layer of weird own ideas. So for the third part, let's draw some conclusions from this. I think what Dennis said about learning from history is really important. Don't reinvent the bike, because it usually ends up something like this, and it doesn't work. So reuse your code, but reuse the ideas as well, the conventions, everything. Code, you already reuse that, I'm sure. But it's code, it's ideas, like the rule of thirds. That's an idea. Reuse that idea. And build new things. Don't build the things that are already out there. Use your energy and your time, it's limited, to do something new. And I think someone who put this in a really good way was a giant robot dinosaur that you might have seen on Twitter. And he's famous for his posters. For example, this one, that the best way to just change the world is to do it. And if the servers are not on fire yet, then you should just code harder. So he said something that I like a lot and that I think of all the time when I'm working. And that's that the most important step for building your product is building your product, not doing something else. And as usual, I'm speaking really quickly, so that's all I had to say. But feel free to spend the rest of the time asking questions. Thank you.
Есть ли вопросы? The questions in Russian is also ok, yeah? And you will get the translation.
Should I use this?
Probably. Есть ли вопросы на русском или на английском? Был вопрос, будет ли выложены ссылки на презентацию, поскольку я поняла, есть опасения, очень много важного кода не упустить. Они будут, обязательно будут. Собственно, вот ссылка есть, но кроме этого на сайте. Есть вопрос?
Sorry, this is not working yet, so if you can do it in English, that's perfect. Yeah. Now I hear.
Yeah, English, okay.
Okay.
One question about performance of Node.js.
Yeah.
Did you have real production experience?
Definitely, yeah.
So how is
it
performed?
People always keep talking about that, and there's benchmarks all over the place, like this is better and this is better, and I found this and we found this and so on. Obviously, this non-blocking idea only works if you're disk-bound. If your problem is that you're writing and reading a lot from disk and you're spending time waiting for that, then it's good performance. But if you're spending most of your time doing CPU-heavy things like calculations and so on, Node is not going to help you at all. So in that case, you're better off sticking to something that's a lot closer to the machine than JavaScript is. But for all like general purpose things that I've touched so far, it works perfectly.
If we are speaking about just simple web application without complex calculations, it fits well.
Sorry?
Node.js fits well for such requirements.
If the requirements are, what did you say?
Not to calculate a lot. I mean, just read small pieces of data and... Yeah. Reading and storing data a lot, that's perfect for Node. But if we want to do some difficult calculations,
yeah.
Complex calculations,
yeah.
JavaScript is not comparable with Java, for example.
It's not optimal. It's not designed for it. It's not helping you to solve that problem. But I still haven't had a case where I'm doing something fairly normal and encountering problems when using Node. So that you are right. It's not suited for heavy calculation, but it has to be really heavy to be a problem because the JavaScript interpreters, I mean, V8 at the moment is actually really quick.
Thanks.
We are currently starting a project, and we are having some kind of a fight about Express versus Flatiron.
Oh yeah.
What would you suggest?
Well, it's potato. It's different ideas. I think Express is, you're going to find a lot more resources when it comes to Express because a whole lot more people are using it. So there's more documentation, there's more plugins, more discussion on Stack Overflow. Yeah, everything. There's more of everything. Flatiron is a little bit cleaner, I would say. Maybe actually a little better if you were to just look at architecture, but I'm still using Express because that's so much more popular.
Okay. Hi.
Yeah. Hi.
So one of the things is that you have to convince your company to work with Node.js, for example, and it happens that a lot of DevOps and sysadmins and whatever think that this is kind of a not stable environment.
Yeah.
They don't have a control on it, and since they are going to be awakened at night if everything fails, they're forcing you not to go for that. How do you convince them? Is there a way that you can convince them that is enterprise ready or something like that?
That's a tough question. That's not computer science. We need some other kind of conference. But I think the cool thing about Node.js and why I also believe so many of you already know it is obviously it's JavaScript, but also it fits well into working with front-end related tasks. Like, I guess a lot of you use Grunt or something similar to work with your JavaScript. And we have things like linting tools and all kinds of processes that we do around our code. Those are easy for us to write in JavaScript because we're doing a lot of JavaScript already and we have a lot of code that we can reuse and so on. So I think the answer to the question begins in that we start using it not for the production systems that actually run in the backend, but we start using Node for our own little tasks, for experimenting, for solving our everyday problems and so on. And then we gradually realize if it works well or not. And when we start to use it, if all the employees at your company were to use Node for their everyday issues and tasks they want to solve, then you already have like a huge argument to back up your idea that it should be used like officially in the company.
Yeah, the thing is that anyway, at some point I will get to you and say, I want a compiled language because you know I have control. I know if it will fail upfront. So for the tools, they are keen on that because if it fails, it's up to you. But when it goes to production,
that's
so
right.
It's great for startup environments and like that because it's perfect for it. You can experiment.
And that's a good point as well. It is less mature than a lot of other technologies. It's not like the DevOps are bad guys that just...
Well, a little bit, maybe.
A little bit, yeah. There's a fact in there as well. Pretty much anything else we can use, like Java or C# or these days even Ruby and Python or PHP are more stable than Node. They have been around longer. But there are a lot of systems running on Node, so I feel that I can trust it. But I understand the DevOps, and I understand that in a large organization it might not be feasible to convince them. I probably wouldn't even try it, but start a fourth company instead.
In our application, you use only Node.js or mixing technology?
Oh, sorry, Node and?
Mixing technology.
Oh, yeah. Currently, the company I work in is so very small. We're 3 people. So we don't have time to use a lot of technologies. We use Node on the back end and a lot of heavy clients on the front end. So lots of JavaScript everywhere. But in my last company, where we did all those billions of writes, we were using pretty much all technologies that were around. Like we were using 4 different databases. We were using Java, Ruby, JavaScript, and even some Scala on the server. So 4 different languages there. It was not just one server. We had a number of servers doing different tasks. So absolutely, there is no silver bullet. Everyone knows that. Node is good for certain things, and I think those things in particular for me are getting things up really fast, prototyping things, and reusing what you already have in client land. So if you want to move the things from your client to your server and have reuse on that level as well, then it's great. But it's not great for everything.
Thank you very much for your presentation. To continue previous questions, I would like to ask, as we know, very huge systems such as Facebook uses Node.js. So maybe you have any specific recommendations or specific examples of tasks which we can delegate to Node.js?
Actually, the obvious example where it's good is when you do real time. I mean, WebSockets and those kinds of things. You are pushing from the server to the client. That's really convenient to do in Node.js. And the event-driven model suits that very well. So that's a clear example. And also, I would say that just the average application, if you take something that is not complicated in any way, but just very, very typical, there's nothing, absolutely nothing that stops you from using Node.js for that. For example, like a blogging engine. It's not worse off than any other platform, except for maybe that the DevOps won't accept it. Yeah?
How do you think in future maybe Node.js can replace such technologies as PHP or maybe ASP.NET?
Yeah, that's what everyone keeps talking about, the future. I like to talk about now and creating something usable now, but I don't know which technology is going to win. But PHP is just bad in every way, so it will be replaced. And I don't know if it's Node or something else, but yeah, something will replace PHP.